Hi, my name is Jen Seinitz. I am backend-oriented developer at Behave. I was born in Soviet Union, where I had an amazing childhood. My best memories are related to Novi God, literally New Year, the New Year's Eve celebration. The main figure of this holiday was Ded Moroz, or Grandpa Frost, the Russian answer to Santa Claus. According to tradition, every December, Ded Moroz, prepaid by my mom, visited me at my family's apartment. All I need to do to receive a gift was to tell him some winter poem. So I climbed on a stool and I blurted out all I knew about winter. And I always received a gift. Now, imagine this gift-giving schema as a software application. Let's assume our application is based microservices. At Behave, the company I'm working for, we just made the transition from monolithic architecture to microservices. So it's kind of a bridge from my past to my reality. We have here a kid microservice, a Grandpa Frost microservice. My mom is a user. She's using a public API, a phone, to communicate with Grandpa Frost. Before this application is going to the cruel production world, it must be tested, well tested. We really don't want to upset mom because her child didn't receive a gift. Well, a bit about my high-tech career. I started my way as a QA engineer, so I have a long-term love story with tests. Long enough for experiencing the overtesting side effects. Long enough to understand the biggest challenge in testing is knowing when to stop. Based on my experience, I created some guidelines that help me to cover the feature functionality without overtesting it. But before we diving into testing water, let's take a look at microservice structure. Most microservices have the same structure. It includes some form of interface, domain, and persistent layers. When it's coming to testing, we want to cover each layer separately. We want to cover the communication between services within microservice, and we want to cover the communication between microservices within the entire application. Unit testing run on the smallest independent piece of code base. Ideally, unit tests depend on single dependency, on a single tested class, which makes this test low cost in writing, maintaining, and running expenses. Often, the low cost of unit testing lures us into the trap of overusing them. Let's assume our microservice has some kid activity service. Okay? This service is ready to be tested as a unit. It includes some telling poem activity, which calls poem service to retrieve the latest learned poem. How great a temptation to test these services together. However, poem service have its own dependencies. It depends on poem repository and on, let's say, mom's help service. Will we include these services in the unit testing boundaries? Whichever way you choose, from my experience, if unit tests depend on more than one real dependency, you will face some side effects. The setup will become more complicated. Quickly you can find yourself writing component tests using unit test tools. Changes in poem service likely will break the kid activity unit test, so the maintenance will become more complicated. In addition, the bug detection will become more difficult. The higher borders, the more places to hide. From the other hand, the overusing of mocking slows down the implementation process. So, before you're writing the unit test, consider its value versus maintenance cost. Or just follow the rules of thumb. Test only classes that execute business logic. It will squeeze the unit testing boundaries to a service layer. Try to keep your unit as small as possible. The isolation of unit from other dependencies will have positive impact on maintenance and bug detection. Now, when your unit is isolated, achieving full scenarios coverage is possible. On top of that, this is a place to cover the edge cases and the different parameters variations. So far, we have a good coverage of separate classes within a service layer. It's time to test how these classes collaborate together. It's time to test the microservice itself in isolation. The isolation in microservices level achieved by mocking integration layers, by mocking collaboration with external components. All other dependencies are real, which increase the confidence in our microservice correctness. From the other hand, it significantly slows down the compilation time. For some reason, we find it difficult to stare at the test runner for more than few seconds. Now imagine you're running 1-minute test suite. Within the first 5 seconds, you will predict the test results. Then you will check your phone notification. Then, just for a second, you will check your social media feed, where you will stalk on your friend's picture from his latest vacation, and so on. Meanwhile, the test was completed, and now computer is waiting for you. I want to point here on a dual side effect. First one is a predictable test runner. Predictable test duration is multiplied by the time computer spent on waiting for us. The second is a non-trivial one, the effect of losing focus. Our service, our component testing are critical for a microservice wellness. We don't want and don't need to skip them. Unfortunately, we can't avoid this side effect called losing focus. However, we can reduce it by squeezing the test suite to the necessary minimum. The goal of component testing is to test the API message from the consumer perspective. So don't cut the corners, start each test by message consumption. Don't duplicate the scenarios that already were covered by unit testing. Try to focus on untested scenarios, on untested layers. This test will include the request authorizations, the request validation, and API-related exceptions. Component tests allow us to validate domain data storage, so include data persistence verification in test assertions. The only untested layer within our microservice is integration layer that was mocked previously. The integration layer implements collaboration with third parties, with external components. To test this layer, we have a component test extension called also integration testing. The problem with the integration testing is that you can't guarantee the result consistency. I mean, integration tests have more than one reason to fail. Maybe the external component unavailable, or maybe just break the contract. I mean, if bookstore is closed, the kite will not receive the winter poems book. For this reason, we often prefer to ignore the integration testing from the component test suite. By this ignorance, we can miss the contract break. Moreover, when we decide to unignore previously ignored tests, we can find them broken. Maybe we just made some refactoring and integration layer. It can be broken. And post-factum test modification requires more resources than ongoing maintenance. So to mitigate the flaky results problem, write only a handful tests to cover the basic success and basic failure scenarios. Okay, now we're pretty confident that our microservice works as expected. Let's continue to end-to-end testing. By end-to-end, we want to verify our application meets the requirements, our application achieved the business goals. Our mom have an ability to communicate Grandpa Frost, and Grandpa Frost coming in time, kid received a gift, everybody is happy. End-to-end tests have large boundaries. It fills the gaps between microservices. The wider boundaries, the higher the confidence. The desire to be on a safe side often pushes us to try to cover everything in end-to-end tests, or at least to try. Don't. The higher the confidence, the higher costs. So, by end-to-end testing, try to cover only scenarios that cannot be covered by component testing. It should be the additional cover for our application. Okay, so treat the application from the user perspective. The strategy is to test only business use cases scenarios. The application behavior is fully tested. It's time to summarize what we just talked about. So the goal was to test application functionality without over-testing it. We started by unit testing, when we should try to keep the unit as small as possible, and we want to limit our unit testing to the service layer. When it's coming to component, we want to cover the scenarios that weren't covered previously. And we will start by message consumption, and we will finish by persistent assertions. By end-to-end testing, we want to cover the scenarios that weren't covered previously, and we will treat the application from the user perspective. That's all. For more content, please follow me on social media. Thank you.